You're live.
Hello. Hello, everyone. We are here to talk about the evolution of the Java ecosystem. And the first question is, it's not the question, but in fact, I would like to ask our speakers here to define Java ecosystem. What can we understand behind that? Which are the main components, like JVM and the other components of the ecosystem?
There's a long silence. No one wants to step forward to name the components.
Yeah.
All right. Go on, Nicholas.
Yeah, thanks. There must be somebody first. Yeah, well, thinking it's a huge question, actually, and it has changed quite a lot in the last few years. So, of course, as you mentioned, like at the core of Java, there is a JVM. And for a long time, the funny part is that people said that the language would like slowly die and they would keep the JVM. And that's very interesting because, yes, there were like new languages coming in, such as Scala or Kotlin. And people started to look outside Java itself to develop. But in the last few years, Java came back in force with like this 6 months release cadence, which, to be honest, is also for us quite hard to keep up with. But now Java is back in full force. And on the other side, the JVM is not super, let's say, adapted to the clouds because you need like startup times that are longer. And now we are looking at other stuff such as GraalVM, which takes the bytecode and makes it native executable. So that's completely opposed to what we were thinking, that Java would die, would keep the JVM. Now we seem to be loving Java, and the JVM loses some of its polish. So that's the first lesson. So don't do any forecast because it will probably be wrong.
Thanks. We already have the first questions, the first question from the audience, but
perhaps I will let somebody else, like younger, tell about his experience.
So I'll answer the initial question of what makes up a Java ecosystem. Now, since I started learning about Java, it's been many years now, I noticed that there are two main components. And of course, now we can look at them as many different components. It's the language and the platform. So initially, there was only Java and the platform, that is the language, and the platform was the JVM. And the language ran on the platform. And over a period of time, in fact, just very recently after that, there were other languages that were born out of it. So the language and the platform make the two important components of the Java ecosystem. And then, of course, there are many other things that grew out of it, connectivity from other languages to Java, Java to other languages. And as Nicholas pointed out, that over a period of time, we had all kinds of different concerns, like recently, or not so recently, it was being able to make it cloud ready, and that problem was solved in a short period of time. And even more recently now, we have the advent, and I'm saying recently, but it's been a 7 years development. If many of us are following, it's the GraalVM, which is Java on Java, or Java written in Java. And what the project is going to do, or is poised to do, is try to theoretically replace every component of the JVM that's written in C++ with Java. And they've already started doing that. Like, for example, C2 compiler, which was written in C++, has been rewritten in Java, and it's called the GraalVM compiler. And they're going to be doing that to the other components as well, the garbage collector, and you name it. So slowly, the ecosystem will be replaced by Java itself, and there'll be very little or very less of non-Java components in there, like things written in C++ or assembly. And now you're able to run programming languages that were, or write programming languages, or rewrite them that have been outside the Java ecosystem and bring them into the Java ecosystem. So you can now run Python, R, Ruby, Shulong, which is a C++ component. So the Java ecosystem is actually broadening quite a bit. It used to be just the JVM and Java the language, and then it became Java the language and other languages like Groovy, Scala, Kotlin, and JRuby and Jython. These were the replacements of Python and Ruby on the JVM environment, but it was still a bit close. You had to still write things that the ecosystem understood. And so now the ecosystem is broadened more than that. So if you see there's a third layer coming out, which is languages written in Java using the Truffle framework that runs on the JVM. And again, the problems of small footprint, of high performance, all of this is resolved with the advancements of the JVM, but also the new technologies that GraalVM has brought in. So we no longer have two components. I think there's a third component that is actually built on top of the two components. And that's where the ecosystem is going. So slowly, before we even know, all of the programming languages that we can visualize and think of, the current ones and the future ones, could be rewritten using Truffle framework and run on the JVM. And so the JVM becomes ever more powerful and important component. And the JVM is getting smaller and faster as well, given that all the components of the JVM is now being rewritten in Java and rewritten with performance and footprint in mind. So it's not only going to get smaller and faster, but also able to help you interoperate with other programming languages that we weren't doing so well in the last era. That's my kind of understanding of the Java ecosystem from my perspective.
Okay, interestingly, I think let me start with the fact, I think the first time I heard about Java was with the news that Java is outdated in 1998, when I had not even written my first program, interestingly. And we are here more than 22 years later, still using Java day to day. And also, another fact I would like to bring in here is that when Java started, of course, it started as a platform independent thing. Though Java could run on multiple operating systems, Java was the only language what you could make use of. On the other side, .NET started with multiple languages, but it would run only on Windows operating system those days. And from then, we have seen how, say, Java has become a true platform. Initially, we would use the term Java to refer to the language because that is more important to the developer. Of course, there is a JVM which has to run on multiple operating systems, which is for very special people who develop these, and majority of the developers would use Java. So I think Java from then till today we mean the entire ecosystem. Anything that runs on Java, we would call as Java, not just the Java language. So I believe when I use the term Java, it refers to the Java ecosystem. And if I want to talk about Java, the language, I would specifically say Java language. Another important part I would say is I started with Java in maybe 2000, but I started with 1.2. Typically, when I would talk to people from the industry, many would say that, oh, Java is slow. We wouldn't use Java. We would use C++ instead. And from there, we have reached a place. I don't think we are talking about Java is slow because of that. I'm using another language. That's another important aspect wherein we have seen Java evolve. And a very important part of the ecosystem, I would say, are the languages. So we do have the languages like Groovy started as a main way to boost the productivity of developers, though dynamic typing was the approach followed in those days. over a period of time, we have seen Groovy embrace both, it can be, statically typed as well. And we have seen more modern languages like Kotlin and some functional programming influenced Scala, and Clojure on the other side has a very highly opinionated small community, which is pretty useful in certain places, as long as you stick to those opinions. One language, I believe, there were also efforts to bring in Haskellish, coding into Java in the form of Frega and Ita, but I'm not sure if those have grown beyond the initial experiments. So with that, yeah, I would say, of course, Mani has already mentioned about Graal VM and cloud readiness, those aspects, which make Java very rich and very useful for today. Yeah, thanks.
Yeah, let me also add a few words. So it has been very rich across multiple aspects of the platform, because especially for Jakarta EE and on the server side, in many cases, the platform is much bigger, although there are more trends in recent years to go serverless. Runs on a desktop could also host a server like Spring Boot or Microprofile and similar approaches. We also had Java on very small devices. I think the Java card and credit cards is still predominant and probably the biggest number of deployments out there all the time, even in the cloud. But for example, Java ME embedded has almost vanished and died, mostly because devices got a little stronger, and you can have something that runs on a Raspberry Pi Nano or some very small, almost credit card sized system on a chip, but you can run at least Java SE, especially from Java 9 onward, that allows to make the JVM itself as compact as you need. So there was almost no need to have something that's even tinier, because hardware was evolving and was cheaper and was more available. So that's, I guess, why Java Card will definitely be important, even though that's probably one of the few parts. We talked about open source yesterday, and Java Card is one of the few areas that's never been completely open source and probably never will be. But below that, or between Java Card and SE, the need for the mobile and compact embedded Java has almost vanished, probably to some extent because of Android, and on the other hand, of course, because SE and desktop has become cheaper and smaller, and you can usually you may have more power on your phone now than you did on a giant server cluster or blade a few years ago.
I think when you mentioned Java Card, it's something like this, right? I was given this at a conference. It's called Code Card,
we have questions.
but you can run.
Can you hear me now?
Yes.
Let me start with the first question.
Did something happen with our connection?
Yeah, it seems she has a bad connection.
The question sent her into the rabbit hole.
That's funny because I have a lag between the sound and the video.
Is his screen here still, or is he?
No, he also has bad connection. Okay, so on Slack, she says that we should answer the first question, which is how was the ecosystem when we started? So I will try to answer that. And as for me, as I wrote in the chat, I started playing with like Java 1.1, but I didn't really start coding professionally until Java 1.3, or perhaps it was 1.4, but Java EE 1.3. And at the time, you must understand that it was interesting, but no fun at all. Because, well, if you are used to Maven as a build system, or Gradle or whatever, at least you have dependency management. So at the time, you had no dependency management. There were no open source frameworks to speak of, really. Every company, at least in France, started to develop its own framework to just not reinvent the wheel in every project. No unit tests. And I mean, the first time I was shown something like unit testing was like, hey, look, what you can do is into the main method of each class, and you can run it and you can see the output, and oh, crazy, you can already check a bit if the code works or not. As I mentioned also in the chat, we didn't have Eclipse. The only IDE which was free at the time was Borland Java Builder, I think it was called, with version 4.
JBuilder.
Yeah, JBuilder, thanks. Borland JBuilder. And actually, yeah, after version 4, it was paying again. We used the IBM IDE at the time, and the code was not, when you imported the code in the IDE, it was not stored as individual files on the file system, but just one gigantic blob called the registry, and the registry got frequently corrupted, so you had to copy the registry from your friend. No Git, no Subversion. I think we used CVS at the time, but yeah, that was. Imagine it was like you were trying to create a plane with only stones. Very, very interesting times. At least that's how I remember that time. And now you just open your IDE, you just use Maven, even if you are using IntelliJ, or you go on like Spring.io, start.spring.io, you click the dependency you want, and everything is done for you. I mean, now I feel more like an integrator of bricks with just some configuration than a real developer, which is also fine with me. And perhaps now I have talked enough. Somebody might want to give his version of his story.
Yeah, maybe I can pick up. I was quite lucky that I was exposed to Java almost when it started. So I think the first version that we also worked with professionally for my main client at the time was at least 1.1. I think 1.0 was probably still a little experimental, but we worked with 1.1, and among other things, we were involved in creating an EJB-based application server for a big customer, some pension fund, I believe, and that was also when that customer, thanks to some people that we knew back then, actually my ex-wife is now in Sofia, and she also attended Java 2 Days once or twice as a guest, but at the time they lived in the US, and so we were able to stay with some friends during Java 1 because back then I think Java 1 alone had somewhere around 20,000 people in '98, and that was literally the year when J2EE was born and first introduced. So that client sponsored part of my Java 1 trip, mostly the ticket and probably also some of the flight ticket, but we didn't have to pay for the hotel because we were allowed to stay with somebody in San Francisco. So I especially witnessed the birth of Java EE, or Jakarta EE as we now know it. And the client also had some of their projects that involved creating J2EE 1 and EJP 1 compliant application server, which of course also was a lot of fun and gave us a lot of insight that helps me almost all the way until now. So one of the major differences was, of course, back then, except JBoss starting under the name EJBoss, and I also looked at it when it started, and I think it was changed. Even then, they changed several times the code base and names and lots of things, so that has continued almost until today. But there was a lot less available in open source, especially on the enterprise side. So JBoss was probably the only really serious competitor that also still survived until today. And other than that, most of the others were WebLogic with BEA back then, and IBM WebSphere and several others, but they were all closed source, so you had very few things to compare, and there were a lot of things that we actually had to learn very hard, and that's why visiting Java 1 was a very welcome course. I think I even got one of those Java rings, which is also the Java card compliant technology, but unfortunately, because I moved dozens of times all around the world, I don't have the ring with me anymore. But yeah, that Java 1 was definitely a nice experience, and it took me more than a decade until I came back. With JBuilder, there's probably also an interesting story that at another client a few years later, we were supposed to replace some legacy product that had very big license costs involved with a big bank, and we had JBuilder, but somehow the license server was broken and didn't work properly in Austria, so we couldn't get it to run. And then with very fierce concerns, and they were almost afraid of that open source technology back then, but somehow, especially because of the deadline, myself and a few colleagues managed to convince the client, a large bank in Austria, to try out that new Eclipse thing, because it was free and it was more easy to use, at least until they were able to fix the JBuilder license server bug. And that was one of the reasons why we actually met the deadline and helped them save, well, leaving aside the license costs, but the project itself, we helped them save, I guess, at least several million. I think it was already starting to be euros, but at the time it was still Austrian shilling. Million or more by using open source at a time when it was still considered very radical, and many of the banks had policies that prohibited it. But a few years later, at an Eclipse demo camp, that very same bank had a speaker sent there, so they actually ended up also contributing to Eclipse and the IDE that a few years earlier, we had to almost force them to use in order to meet the deadline of the project. So yeah, back then I sometimes ended up learning a lot of things by doing them and learning them from the source, but that's also because because of that I'm now also sometimes in lucky position that I've been involved in some of these ecosystems for quite a while.
Interestingly, when I started, I mean, at least learning and trying it out, not professionally though, just for a few minutes, maybe beyond that. Those days I used to have like 128 MB RAM on my PC, but the IDEs wouldn't work beyond first 10 minutes. So I had to stick to plain text editor, something like Jdk, I believe what I was using. And interestingly, due to that, I had a lot of the APIs fluent, and I could use without really, requiring auto completion or anything those days. And even before I started my professional career, I had a chance to use JUnit. Because the reason was that I was looking at design patterns, and somewhere I had read that JUnit is a good place. It's a good open source library to look at the use of design patterns. That's how I started looking at JUnit and started using it. Even before I started writing code professionally. But I think that helped me very much later on when I started my professional career. Thank you.
So I'll try to pack in that question and maybe the other following 3 questions in one go, so that the next time I speak, I have another different question. So I quickly started using Java, around the first version when it came out. And at that time, there was no IDE. All I used was Notepad and a command line editor. And I actually was using it on Windows and not even Linux or another operating system. And then there was a short pause. And before I could next start using it was only when I started looking at Java 5 or Java 6, maybe even. And at that time, we had Eclipse. There was less command line usage, but nevertheless, a lot of IDE usage, and Eclipse was good enough to give us enough of the auto-completion and other IDE goodies. And at that time, I also started looking at the best practices that a lot of Java developers did. Luckily, I was able to liaise with a lot of, like being in London, I was able to liaise with a lot of the community, including the London Java community and the other communities that sprung out of it. And so, as Naresh mentioned about JUnit testing, and Nicholas mentioned as well, that became a de facto work method in the Java ecosystem. And so you can understand that starting from no test unit, like in the early versions of Java, not many libraries, all the way to when I started looking at Java 5 and Java 6, there was a vibrant community and people were talking about garbage collection and performance tuning, and there were lots of open source libraries. So that was a massive boom and people also, like when I started looking into Java again, that's when I also got introduced into the community that I could contribute back to Java. So if you'd like to know how to contribute to Java, look at the Open Jdk project, look at a lot of the open source projects like Spring, and GraalVM itself has a massive contribution opportunity there. And so it's really hard to tell you how to really start contributing to Java, because it's such a huge ecosystem. No matter where you look, you'll find an opportunity to contribute to your library, maybe just the documentation part of it. Just start a pull request to improve the documentation of a library, or raise an issue saying you have found this problem in the library. And that could basically help you also get started with your contribution aspect of your career. And if we have to answer the question, what were the roles of the tech giants in the evolution, I would say a lot of big companies opened up their open source their in-house projects and in-house libraries. And also at the same time, like if you look at some of the major contributors to the Open Jdk project, there are some of the big companies like SAP, Microsoft, Red Hat, IBM, Oracle itself, and the list just goes on. And And they are not just contributing to the JDK as a JVM, but they're also contributing with other libraries. And Red Hat especially is taking on the job of hardening some of these open source libraries and making them available open source to the public, and doing even more service to the rest of us in the ecosystem. So I'll sum that up to some of those questions, and just want to have a quick look at what programming language compared to Java changed with the other programming languages. So Java has been maybe different and slower in its evolution, and the maintainers and the architects of Java have a good reason for that. And there are lots of talks on that, and maybe we should share that as a separate link. But the advantage of coming up with your own language on an ecosystem like Java is that you are allowed to share your ideas and your methods of working and your ideologies of how a language should work in an open ecosystem like Java. And so Java, the language itself, may have taken a different course than many of the other languages. And slowly Java, the language, is adopting a lot of the goodies of other languages, but the pace is much slower than many other forward languages. And sometimes they have even crashed. And I wouldn't name any of them because they're probably fans on this channel. But you can follow them up to see what they could be. So I'll rest my words here because I must have covered all the 3 questions. If not, Eva will point out to me anyways.
There is an interesting question in the chat. Alexei asks, what does it take to become a speaker like us? Well, the thing is it takes just the willingness to take some risk, to go out of your comfort zone. I started talking just by going to my local user group, and yeah, they accepted my talk, and then I never stopped. And I believe that everybody can do it. I see a lot of people having very interesting experiences, and the same people, they are very afraid to go on stage and say, but I have nothing to say. Well, it's not up to you to decide that. It's probably up to the conference organizer or to the attendees. So don't be afraid, take some risk. It's perhaps not comfortable the first few times, but after a couple of times, it's very energizing. I mean, of course, if you are online, it's not that energizing, but to get feedback from a room full of people is very, very interesting. There was another question, how Java has changed over the years compared to other programming language. That's also an interesting question. Like, for a long time, like, it was mostly like by bits and pieces with Java and .NET. Like, Java got an advantage, and then it didn't evolve for some time. Then .NET added some interesting features, and let's say like Java, like for a couple of years, tried to get like again added benefits, and it worked pretty well, as Manny mentioned. It was I think that's the huge success of Java is mainly because it is very stable. It is backwards compatible. I mean, you can run pretty much any version of all application on modern JDKs. And when the people behind Java changed it was like with Java 8, 9, 10, and you can see that it has a massive impact. Of course, the language itself is evolving faster, but the adoption of the latest version is much, much slower. So it remains to be seen whether it was a good idea or not, because it's a tension between your release cadence to please the developers, to provide new features, and the adoption rate. Like, at least half of the developers in any room, they still use Java 8. They didn't move to Java 9. And we are nearly at Java 17, which is crazy. So, I mean, I'm a bit worried about that. Also, not to mention that the Java 9 with the module systems probably didn't help things. And as you can see, also the adoption of modules among libraries is quite, let's say, sparse at the best. Another question, and then I will shut up because I also need to let other people know. Yeah, about contribution. Contribution is very interesting. Also, the step is not that huge. You go to products or to frameworks you already use, Spring, Java, whatever. And for example, on GitHub, you probably have labels like good first issues. Those are quite easy to use. I mean, even if you are a junior programmer, which sometimes I feel like right now the pace is so fast, I cannot cope with it. You can check some good first issue, then you go to the community Slack or Gitter or whatever, and then you can ask for help if you don't manage it. But most community I've been part of are very, very helpful. You can see in the Spring community, in the Kotlin community, Java community, of course the Hazelcast community as well. And yeah, just go on GitHub, find good first issue. Also, as many mentioned, you don't need to know how to code. Documentation, it's always good stuff to make improvements.
Okay, let me share my story of becoming a speaker. So back when I was working, I kind of realized that there are a lot of common, Java-related knowledge which could be shared between the projects. I mean, between people working on different projects. Hence, I started a Java user group within my organization. Usually we used to have like 2 meetings per month kind of, and sometimes the speaker who I invite would say, okay, now I'm a little bit busy, can I speak in the next slot? So I didn't want to really postpone that meeting, so I used to have a backup talk ready by myself. So I think over a period of like 1 or 2 years, I was the one who spoke most. And later on, like I was attending some conferences pretty often, and some of the people, regular speakers there, they saw me that, okay, I'm pretty regular, and they knew me, and they encouraged me to, okay, why don't you submit a proposal? That's how it got started. And regarding with respect to the question on contributions, I think try to create value. Of course, whenever you are, say, using a framework or library, you might want to understand certain things with more depth. So in that case, since if it is open source, you always have the chance of looking at the source. That's how I ended up looking at source code of several projects. Once that you might see that, okay, certain improvements might be very helpful to you in the sense to your current project. For that sake, you could make certain changes. And once it is useful to you, I think you can always contribute it back to the project, apart from the other points people have already mentioned. Thanks.
So I'll chime in about my speaking career, and I would say that writing blogs. Well, I can't say if there was an order, but I would say starting to contribute to an open source project led to me writing blogs, which led me to speaking, and then there was a cycle that was not in any particular order, because when as a developer you're also a sort of a evangelist. You're sort of a spokesperson who speaks about the project you're passionate about, the contributions you've done to it, and so you end up going onto the speaking circuit. And so luckily I was part of the LJC speaking circuit, where we would constantly speak at various events and conferences, and that's how I came across Java 2 Days as well. This was about 5 or 6 years ago, and I'm thankful to many such conventions and conferences, including Java 2 Days, for giving me the opportunity, including the one this week, to speak. And that's, and once you break the ice, then there is no stopping you. Then you want to speak at as many conferences and submit papers at as many places. And so there is that just one, as Naresh was mentioning, and Nicholas also mentioned, you got to just take that first step, and then there is no recipe or procedure or process. I don't even remember when I took my second, third, and the remaining steps. But I do know that the first step was just stepping up and saying, okay, I want to go. We had to stand in front of 10 people and say something for 5 minutes. So you want to do something shortest and simplest first, because you can imagine in 5 minutes you can speak a lot. Like, you can already see in the last few minutes I already said so many things, and each one of us has many things to say. It could just be a small feature in the Java language, or a small feature, or something you learned on the command line, or some flag you know of that you think it could have been improved, or some documentation issue. And every bit of these contributions you make back, similar to opening a pull request with just a documentation change, is similar to doing a talk, which is just talking about a line in the code or a documentation issue, or an improvement in documentation, or how good a certain documentation of a certain library is. There are umpteen number of topics to pick from. And so there is no one recipe or one process to do something. And Java Today is a great platform because they are very open to all kinds of submissions. You can already see we have a full panel the last 2 days and tomorrow as well. And so just jump forward and pick your poison of choice or nectar of choice, whatever you want to, and just speak about it.
Okay. So yeah, let me also add 1 or 2 words to this. So since I worked for clients who were way early adopters of Java, I started occasionally speaking already before the turn of the century. So this was roughly around the same time as my first visit to Java 1, although the talks then were not as big. But it was to some extent out of our boss and the boss of the client that I worked with, a local consultancy in Vienna that started using Java way early, and he was also tutor at the Vienna Technical University. I actually also helped as a tutor for database systems, so I was exposed to Oracle DBMS even before Java existed, and helped other students there. So this was definitely a very good way to get into teaching other people by helping them as a tutor while I was still studying myself. And because our client was also giving lectures at the same university, he was invited to several talks, and I think that on one occasion I actually met all or most of the famous Gang of Four that defined the Gang of Four patterns when they gave a talk in Vienna. And on another occasion, Erich Gamma also presented SWT for the very first time, and I had a booth there. I didn't even speak, but I had a booth at a conference that I think was called Java Days, and later they changed the name. It was a little bit like Devox, that they tried to broaden the focus. So I believe then they called it Net Object Days. It was near Erfurt in Ilmenau in Thüringen in 2000, and that was the first booth I ever had at the conference, trying to sell a couple of Java-related products, for example, the internationalization of Swing, many years before Sun actually integrated that into the JDK. And I had a tiny booth with 2 people. And on one side, IBM had a giant booth, and on the other side, Sun had a giant booth, and we were right in the middle. So that kind of activity, helping the clients to either promote their products or occasionally also promote my own smaller, helped me to get to several of those conferences. So Java 1 was probably the only one where I was simply attending and watching and not actively participating, but there were other conferences in Germany and Austria. I believe one was either in Munich or in Vienna. I can't exactly remember, where our boss simply said, okay, sorry, I have a meeting. I'm too busy. I can't speak there. Please, Werner, go there. So that was one of the first chances that I got to speak, and the others came up, of course, from working as a tutor at university. So it's nice to see that some of my successors in the JCP executive committee are now also fostering Java in education, because if it wasn't for education, I would probably not be here, and I would probably not have learned Java as early as I did.
I think we are missing more questions. We want more questions. We need more questions. We beg for more questions. Don't feel shy. I mean, we don't see you.
It's the big data question, or what exactly was that?
Yeah, there's a big data question.
The question is, like, in big data, it seems that Java seems to be the language of choice.
Well, I think yesterday we also heard that when it comes to analyzing data, it's probably a lot more Python. But when it comes to hosting some of these systems, including Spark and a few others, I guess they all run at least on a JVM, and many of them run Java. So except there may be a little more Go here and there, but that's also more on the infrastructure side. And I read a Medium post a few months ago that also said, like, yeah, Go is evolving a lot, but in some cases it's not yet as mature and ready for the enterprise world as, for example, Java is. So it definitely has a lot of important use cases, including the containerization. But it seems when it comes to data representation, that's definitely one of the areas where Java is still a bit stronger. So hosting some of these object and data level, I guess Java is definitely quite strong. When it comes to analyzing the data, sometimes Python may be more the language of choice.
So I'd like to say a bit about the big data question. Is it appears now that Python is the de facto and R are the de facto languages for data processing, and of course, as Werner rightly said, a lot of the other systems that are used to do the rest of the pipeline in the process, whether it's data, it's parallel processing, or handling data at large scale. Java and JVM-based systems seems to be more reliable and stable, and are able to handle that at production and enterprise level, as opposed to Python and R, which are not suited for those kinds of environments. But this space is changing, and Java, the language, is now the only that appears like that. But it's more the JVM that's going to be continuing to be playing a big role, or a bigger role, in the big data space. And you will notice that Python and R are not going to go away, because if you're following the Graal VM project, like some of us here, there's Graal Python, and there's R already available, faster R already available on the JVM. And then just there's the version of Ruby has been worked on, and other programming languages can be quickly written. And then all the code that you've written in your, what we so used to call legacy code, which no longer should be called that anymore, because you can then rerun all of that. COBOL has already been rewritten for the JVM, for the Graal VM. And so you could run all of that on the JVM without even writing anything in Java. And so then you could be doing a lot of big data. We are saying big data on Java now, but we'll say big data on the JVM in time to come. And so all of that work that's already been done in the so many years to come, they can all be running on the JVM. And you will not see any difference. You will definitely notice an improvement in performance and interoperability, which will make the big data world work much more seamlessly.
There is a question in the chat. How the education systems influences the Java ecosystem? I have a personal experience with that, which is very funny. So when I graduated, I didn't study computer science actually, but still I had a few lessons about C and C++, and it was really hard for me. I mean, it was really, really hard for me. Then I learned Java when I started my professional career. And 2 years afterwards, I came back to my engineering school and asked if I could teach Java. So the first year it was an option, and the second year they replaced the C and C++ teacher that had taught me that, and it was only Java. So I just made my previous teacher obsolete. I'm sorry for that if he listens now, which probably he doesn't, but still, I just apologize. But now we see that Java in some universities is being replaced by Python or JavaScript. So I think it's just a hype curve. And yeah, now Java is not hype anymore, which is perhaps a good thing, perhaps not a good thing. But yeah, we have been reading the death of Java since like 2 decades, and it's still there, and it's still living and kicking. So yeah, I think it's a safe bet to continue your education in Java. As we have talked about it already, even if you know Java and you want to deploy on the cloud, just use GraalVM, make your application native executable. You can steal the same tool, you can keep the same ecosystem, all the libraries that you know, all the syntax that you know, and be happy. So Go and Python, yeah, they have some benefits, but if you are a Java developer, life is really, really good.
So Java is like Mark Twain. The news of its death is highly exaggerated.
With respect to the education, I think, I mean, this is equally applicable to any other languages as well. I think one important distinction I would like to see is like typically programming is taught as if like it is done once. You write perfect code once and you run it and it is done. But I think, you know, what is very important is the ability to evolve from how it is today and accommodate the newer requirements and make it evolve. I think that skill to evolve the program over years is something that is lacking in the current education, I think, which is something very important. Say, for example, having some personal projects could, you know, you develop it over years can really help to address this issue.
Yeah, I would say I would plus one what Naresh and Nicholas just mentioned as well. What I'm noticing is that when I am actually informally mentor people, I notice that there are so many, not just soft skills, but so many hard skills that are missing in their tool chest that I thought they would have had because they spent 4 rigorous or 6 or 8 rigorous years in education. And I haven't even gone through some of those. I had to learn through the hard ways, through other strong developers around me. And it has been a lot of sacrifices of weekends and after working hours. But I learned those things that they are not even reading about or learning about in the university. I mean, I don't know what they are learning. A lot of it is theory. And I'm sorry to say that theory is important, but it is also not important if you don't know how to put it into practice. And it doesn't really matter whether it's Java being chosen as a language in that university or in that curriculum. It is choosing all the ways, all the pragmatic thinking, all the best practices, you know, the approaching the things top down and not bottom out, and when to do top down and when to do bottom out, all those important nuggets. And it's actually the whole way of working is not taught, which when they graduate out of whatever degrees they do, and they say they are a computer engineer or a software developer, they are not still ready. Some of them are still not ready for the real world. And that's not very pleasant, because then you have to handhold them for a number of months, weeks, years, and then bring them up to a level that they can then be ready and productive at their workplaces, and then start loving the joys of the language like Java and the JVM. And I'm not sure if that journey is at all pleasant for both sides, the mentor and the mentee. And I think that can be improved and can be made much better.
Hey, Manny, I think I was not ready for a couple of years either when when I went out of studies. So I understand that yeah, it takes a long time to have somebody who's productive. Whether you have been at a university or you did a boot camp or you learned everything in books, but we are in the fast-moving technologies, and I believe that even seniors like us, I mean, we need to regularly relearn stuff because stuff that was done in one way before is not now done another way. I mean, regularly I write stuff, I fail, I rewrite it, and well, I think that's life. I mean, I cannot expect for a long time. I did teach at school and universities and stuff, and I try to like bring industry understanding in those like organization. But most of the schools, they are like the lessons they are taught by professors who actually are very interested in theory and in their research, and they are mostly not interested in industry and how it works in the real world. So some of them are, and that's real good. I mean, we need more bridges between those higher education organization and the industry, but most are not. And yeah, that's bad, but that's how life is. So I will need probably to a question. How do you see the Java?
We have another question from Bongo. He's asking about how do we see Java ecosystem in 10 years?
I believe that anybody can tell you anything and it will be wrong in 10 years. I mean, yeah. I mean, even 2 years is a bit far. In 1 year, we can believe that it will be more about like more evolution from the language and more native image stuff. But like beyond that, all bets are off. All bets are off. Remember, at the time, there was a technology called Flex. It was super great because, I mean, you could develop once and it was displayed in every browser in the same way, regardless of the implementation. And Steve Jobs just killed it by saying, we don't want Flash on the iPhone. And they just kill Flex like that. So everything that can be said, it will be like probably wrong in 10 years. It's conjectures.
Yeah, I think I'll totally agree with Nicholas on that, because look at it. For how many years have people been saying is Java dead? I know there's a very brilliant but also funny guy in the LJC who keeps, every year we have an unconference, he would come up with the talk, is Java dead? It'll be like a 5-minute talk, but he'll still bring it up. Of course, lots of people wouldn't vote for the talk because people knew he was joking, but also that we knew Java wasn't dead, right? And it's been going on for so many years. So there are new variants and new languages coming up on the JVM, but Java, the language, is still persisting. And you can already see the progress it's making. And we are already expecting a new version every 6 months. So that means there is a lot of force being put on there. And the platform that we now have to develop on, like the Graal VM, and as Nicholas was mentioning, native image is bringing a lot of progress. That itself it's going to take a life of its own. So we don't know where all Java will go and what it'll become, because once it becomes a native image, is it Java? It's debatable. I mean, you can say there's some Java in there because there's still a garbage collector and a very tiny JVM running inside a native image. But then there are many, many such innovations and developments that will happen that will make it hard for us to, as Nicholas says, come up with even conjectures and prove that it's going to be right.
I think I remember predicting back in 2005 that XML is going to be the center of all application integrations, and I'm happy I'm wrong. I think what's important, or as an alternative, what we need to look at is how our technology is evolving to the demands. Slowly, we need to take smaller risks and keep embracing new things or keep experimenting with new things. If we don't take small calculated risks over a period of time, I think that is the biggest risk we are taking.
It seems this is the last question, so whoever hasn't stepped in with their last words, please do, and so we can close off and wind off really quickly. Werner, did you have to say something? You didn't say anything.
I think it's time
Can you
for
repeat the
time
question?
off.
Because I have a better connection than Iva and Iskren, but I do sometimes see the questions up to 10 minutes later in the chat. Last time Nicolas answered one, I saw the actual question probably 5 minutes later. So can you repeat the last question? So I'm sure
Yeah,
that I either
the question
overlooked
is,
or I didn't see it.
The question is, how do you see Java, the Java ecosystem in 10 years? It's a common interview question.
Now I see.
Yeah, I just repasted that question again.
Well, I definitely think that Java is here to stay. If unless there's any giant big issue coming out of a Supreme Court decision next year, but hopefully, at least looking at some of the decisions they made around the election, not all of them seem to be always exactly as tragic as some people had feared. So let's see how it comes out. But unless any of that was to completely derail the participation of some of the major players or kill or stifle the Java community process, I guess both Java and the JCP are likely to exist for at least another decade or more. So we'll probably see the JVM maybe even exist and evolve longer than that, but at least for the next 10 years, I definitely see Java still around. The popularity may shift in some cases between Java, JavaScript, C, and a few other newer languages, but I definitely think it's going to be around at least for another decade or even more. So if you look at C and C++, especially, some of these languages are 50 years plus old in a few cases, and I guess so with 25, Java is only half that age. So I'm quite confident that it will also be important enough, at least for another 25 years.
Okay. All right. Good words from Werner. So that was the last question. I think everybody got to chime in into that last question, and we more or less agree with where we think Java will be in the next 10 years. I mean, we could also be wrong, as Nicholas pointed out. So let's hope for the best and prepare for the worst. So with that, I have been given the task of closing this discussion. Thank you very much for all the speakers, and especially the organizers, Eva and her team. I think it's they've done massive amounts of hard work in bringing this conference together, and this happening for the next couple of days now. And thank you very much for being here, and enjoy the rest of the sessions today, and hopefully see you for the next discussion that will take place in a couple of hours from now, or an hour from now, actually. All right. Thank you very much.
Thank you.
Okay.
Take care. Bye-bye.
Thanks.
Bye.
Have a good day.
You too. Bye.
You too.